All right, so for the next video, we're gonna do the 9-inch housing for the hot rod, but we've got a work project to do. What we have to do is drill a grid of tapped holes in this back panel for an electrical box. It's so he can mount various things in here and have the flexibility to change things in the future. So almost a solid block of holes in this thing on 1-inch spacing. And the challenge is this thing's nearly 20 inches this direction and way over 20 this direction. And that is more than the travels I have available, at least in the X. We'll be able to do maybe 2/3 of it, and then we'll have to move it, reposition it, pick up a point, and finish. So this is the next thing. First, what we have to do though is take the vise out. And I looked, this vise has been in here. It's never moved since I got it, and it's been about 6 months. So we will see what the table looks like underneath the vise and the bottom of the vise. So when it's out, I give it a very good cleaning, get all the kind of gook that's stuck on there, the coolant that's as it evaporates, leaves all the solids behind. Get this guy cleaned up and ready for going back on. But let's get this off and have a look at the table. Okay, vise is out, and that's what we're left with. This looks like a bunch of kind of just grease, oil deposits, a little bit of discoloring, but we'll clean this table up, get the chips out with the coolant flush, and then give this a little stone and see what happens. Okay, and that's the condition that the table was in after 6 months of having a vise on it. Never pulled it off, and all we did was we used LPS 3, generous coating of that on the bottom of the vise and the top of the table before we bolted it down. And there you can see, barely noticeable. I mean, this table has lines in it running across, milling lines. Kind of the newer stuff, some of the Haas stuff doesn't really have that. Very smooth. So really all I'm able to do is hit the tops of these these ridges to clean them up with a stone. So it's always going to have that dark kind of hatched pattern in it. I suppose that's kind of cool, but it makes it easier to keep things very flat. And anyway, it works. So let's see if we can get this thing mounted in here. Okay, what I'm going to do to find the middle of the table is I'm just going to move this guy back into the corner as far as it'll go, X and Y, and then what we'll do is we'll run a G92. We'll set X and Y to 0. We'll move to the other extent, and then go half, and that will be the center of my workspace. Okay, so we ran the G92, and then I moved it all the way back in the other direction, and you can see as the machine indicated 20 inches of travel in both the X and Y. So we'll go back 10 and 41 thou, and that'll be center. All right, now what I think we need to do is find the the approximate center of the plate. So we'll go corner to corner. This only needs to be approximate. In this particular case, the pattern itself is the only thing that's important. So when we move this thing, because we don't have enough travel, we have to know that we're 1 inch to 1 inch away from the hole, the previous hole. We got to have that 1 inch spacing so things in the future can bolt up. Where that 1 inch grid lays is not that important. So that's accurate enough for a center line. And then what we'll do is, what I'll probably do is project this thing over a little bit so we can do a bit more than half and then a bit more than half. And how far I project that over, that will be where we line it up at the 0 point on the machine. All right, this is what we came up with. So we're hanging the excess off in the Y. So I have area to get clamps in, using little plastic so we don't damage the powder coating on this steel plate. And then you can see that was our center point, and then we went 10 inches in from that edge over there, 10 inches in, with there's like an 1.5 inch border around the outside where there's no holes, so that will easily allow us to hit everything we need to hit. We should be able to do nearly a 20-inch grid, and then we'll move it and pick it back up again. Right now what I have to do is snug these and then sweep the edge, make sure we're square it up, and then we should be able to go. Pretty straight, over 6-8 inches. It's only off by a couple thou, if that. So all right, we got the Mastercam fired up right here, and I got a drill and a tap loaded in. Just window selected all these holes and set a pattern for it so it makes sense, not jumping around all over the place. We can backplot this so we can see what yeah, we're going to start down here in the corner, and yeah, run across, go up and across the other way, and that's what the pattern's going to look like. First drill, then tap. So that looks pretty good. We can send it to G-code. We're gonna not post all, let's just do the drill at this point. Gonna save that off. And yeah, pretty darn simple program, it's just a whole bunch of straight moves. So it's small too. Looks like we're feeding at 9 inches a minute. I'm gonna spin it up pretty good, 3,500 RPM. See if we can get that long drill not to walk around as it goes in. So yeah, we'll send this over to the machine and get started. Alright, I sent the program over to the machine. Let's see what we can do here. Yeah, the caliper bracket was the last one we did, so programs, transfer in, browse. We keep everything right there. There's the grid we're doing. Transfer, start, and then just run that program. Brings it down in. And I can verify if that's right. Looks pretty good. And we'll send it. Okay, we're about halfway. I have a positioner jack underneath that I keep sliding back because the plate wants to deflect too much. Kind of rattles. And you can see it deflect the plate down and pop through. So it's going. Yeah, this machine will rigid tap, but I have, as you can see, I have a floating tap holder in here. It just adds a margin of safety when I'm doing these very small fine threads. So there we go. All right, we got all of our holes cut and drilled and tapped. I went ahead and got a great big, I don't know if this is a 3-inch square block of aluminum, and I'm going to push it up against the edge and clamp it down, and then that will be the edge that we align this thing with when we slide it back. Okay, that's pretty good. Okay, I went through and deburred all these holes on this first line right here, and basically took this little socket cap screw, I put it in the lathe and turned the edge down, so it's nice and round now. And I'm going to count in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to stick this in the 10th hole. Like that. Great fit on the threads too, so that's great. Now what I can do is indicate off of that, and that will be my new zero. So, okay, we got that guy swept in pretty good. Definitely within a half bow. And there's a bigger, wider shot of what the whole setup looks like. So there's 9 holes on this side and 9 holes showing on that side. The 10th one is the very center of a 19-hole pattern. All right, we're all finished up. Got the entire pattern cut in. Now I'll pull it out and do a little deburring. Pushes quite a burr on the back side, so we'll have to take care of that. Okay, guys, I couldn't come in here with a deburring tool on the CNC because this thing is not that flat. I may have been able to put something in my floating tap holder and kissed everything with the same amount of pressure, maybe, but it's probably just as easy to go through and do this.
Okay, I got the important side, the top side deburred, and I flipped it over, and now you can kind of see, you know, what the back side looks like. Got to get rid of all that. We can't have somebody reaching under there and getting hurt. So kind of just spent a minute and did these first few, and this is what it looks like. And you know, I mean, pick a hole and whoops, sorry. Pick a hole and just thread the bolt in. It goes pretty well. Nice fit on the thread. I don't know if you can see that or not, but nice fit on the thread. And this plate, I don't know how thick it is, 1/8 inch, you know, 1/8 inch steel. So we used 1032 tap. So we've got I don't know, maybe three threads ish. Once we run that little deburring tool on there, so it looks pretty darn good. So I just got to finish deburring, and that heavy dog's gonna wear my arm out.
Okay, so we're all finished with deburring front and back, top and bottom, whatever you want to say, of this electrical enclosure backplane. 475 holes. It's a good project. Whip it out quick. Yeah, it's a fun setup when things are a little too big for your machine. So I hope that was informative on how I pick up a new point, you know, using an existing hole. And for this, the accuracy is close enough because everything that bolts to this is going to have a clearance hole, and we're well within 1 thou on this location of this second array of holes. So anyway, there we go. Like, subscribe, and keep following. We'll have more good content, hopefully.